Ever wondered how apps like Instagram, YouTube, or Amazon load data so smoothly? You scroll, more items appear. Scroll again, still no lag. But behind the scenes, those apps are not loading everything at once. Because if they did, your app would freeze, servers would cry, and your internet would suffer. So how do they handle massive data? The secret is pagination. And today, we're diving into how pagination really works in real-world systems. So when an app has thousands or even millions of records, it can't send everything in one response. That would be too heavy, slow, and inefficient. Instead, the data is divided into small portions that load step by step as users request more. This keeps apps fast, servers stable, and user experience smooth. That entire process is called pagination. Two main ways pagination works. There are two major approaches developers use: offset-based pagination, cursor-based pagination. Both aim to do the same thing, but they behave very differently. Offset pagination, the simple method. This is the easiest and most common method. It works by telling the system where to start, how many records to return. So basically, you say, skip some items, then show me the next set. Example SQL query. This means ignore first 20 products, then return the next 10. Two styles of offset pagination. Page number style. Example, page 3 with 10 items per page, direct offset style used in API, simple and easy to implement. Problems with offset pagination. Looks great at first, but it struggles in real-world systems. Issue 1. Performance gets worse. When offset becomes very large, the database must scan tons of earlier records before reaching the requested ones. This makes queries slower and slower. Issue 2. Data becomes unstable. If new data gets added or removed, everything shifts, so users may see duplicate records, missing records, which creates an inconsistent experience. Cursor pagination, the smart method. This is where things get powerful. Instead of counting pages, we use a reference point, called a cursor. Think of it like a bookmark that says, start from here next time. How cursor pagination works. Here's the flow. Choose a unique field, like ID or timestamp. Send it as a reference value. Client requests next results using that value, server returns data, plus a new reference. This creates a smooth, continuous flow. Why cursor pagination is better? It solves major problems. Faster performance, no duplicates, consistent results. Works well with live data. Ideal for infinite scrolling. That's why social media apps rely heavily on it. Types of cursor pagination. Two popular approaches. Key-based pagination uses unique ID. Example, fast and efficient. Time-based pagination uses timestamps, perfect for feeds and logs. Example. Final takeaway. Here's the golden rule: small or static data arrow. Offset pagination works fine, large or constantly changing data arrow. Cursor pagination is the better choice. It's faster, more reliable, and built for real-world applications. So the next time you scroll endlessly in an app, just remember, pagination is working silently behind the scenes to make everything smooth.